Hey guys, welcome back. Hope you all are doing well. Today we are going to solve lab number 12 from HTTP request smuggling vulnerability module. So this lab is about 0.cl request smuggling. Okay, so as we know, the first digit or the first character we took as for the front end server, and the second part of this we take it as the backend server. So 0.cl means the front end server will see the content length as 0 and will not interpret it, and the second part of it is saying that the backend server will see the content length or interpret the content length. So the lab description is saying this lab is vulnerable to 0.cl request smuggling. Carlos visits the home page every 5 seconds. To solve the lab, we need to exploit the vulnerability to execute alert in his browser, in the victim's browser. This lab is expert level lab, and it may take a lot of time to solve it or to fully understand it. Although I would try to explain each and every part. But I will not go into the very basic which we already cover in the previous labs. So this is our lab, and you can see we already have here all the requests. I'm just going to make it a little bit more clear for you so that you can see both of the windows simultaneously. Fine, so this is the request for the web root, and I'm going to send this request to the repeater. So if you see this lab, it's saying that we need to execute the alert function on the victim's browser by exploiting 0.cl request smuggling vulnerability. So basically in this lab, you have to first of all perform the double desync, and the third thing is you need to also find out the part of the web application or the part of this web application where it is vulnerable to XSS. So first and foremost, if you have the professional version of the Burp Suite, you can do it by scanning the application, and it will give you the result where the application may be vulnerable for the XSS. So also you can use some open source toolkits to just scan the vulnerability for the XSS. Fine. So here we have a few things which we will do in a separate part. Then we will chain all of those things to exploit that vulnerability. So the first thing is in this particular lab, if you go to the particular post, so you will find here, this is the request, and basically this request is vulnerable to XSS via user agent. Okay, so I'm just going to send this request to the repeater to just show you how you can exploit the XSS, or instead of sending this to the repeater, you can do it by just intercepting the request and change the value of the user agent. So what basically I'm going to do here, first thing first, I'm just going to change the request attribute from HTTP version 2 to HTTP version 1. This is the most important thing. And I'm just going to do here one thing to change the value of the user agent by saying anything ZZZ. This is the typical payload for exploiting the XSS. So script alert 1, and then close the script tag. Okay, so this is gonna be our payload, and if we send this request, you can say 200. Okay, but here maybe you will not see the things what you need to see for the XSS. So it's better for us to intercept the request and change it while the request fly, or on fly we will manipulate the request. So I'm just going to the proxy, intercept, turn on the intercept, and just refresh this page. So this is the first request which I need to forward. Yeah, this is the request which I need to manipulate. So this is the value for the user agent, which I need to change it. So I'm going to the repeater and just take the value or the payload for the XSS, and in the interception I'm gonna paste this value in the user agent as the value of the user agent. And if you want, you can also downgrade it to HTTP version 1 and send the request or forward the request. And as you can see, the alert is popped up here, or this particular feature is vulnerable to XSS via user agent. Fine, so I'm gonna turn off the intercept. So the first part, we already know now that the application, the post ID, or where we try to access a particular post, this request is particularly vulnerable to XSS via user agent. Now let's go and we already sent the request here for the web root. Now we need to see the discrepancies between the front-end server and the back-end server to confirm the HTTP request smuggling vulnerability. So here in the interception again, I'm gonna downgrade the HTTP version from HTTP 2 to HTTP 1. And the second thing, I would like to do not update the content length. This is also most important. Just send the request to see if it's working fine or not. Yeah, it's working fine, 200 okay. Now I'm just going to change the request method from get to post. And here what I'm gonna try is, I don't need any of these things. Fine. So here, as you can see, content length is 0 because this is 0 CL. We are working on 0 CL. So the front-end server will not see the content length. It will always assume that the content length is 0. So what I'm going to do, I'm going to put here anything, let's say X or Z or whatever you want, and just send the request. We will see the request is 200 okay. The response is 200 okay. Because it's not considering the content length. The front end is not considering the content length. Now, even if, because the body section have 1 byte of data in the body section, but because the front end server is not considering or interpreting the content length, so it is saying, okay, there is nothing in the body. Fine. So even if I put here 1 byte and send the request, you will see 200 okay again. But if I try to put here more than 1 byte to read more data in the body section and send the request again, let's see what happened. Maybe the request timeout to read the content, because the backend server will wait to read the content. The front end server will say, okay, I'm not seeing anything in the body section, and it will send only the headers to the backend. Okay, and the backend server will see the content length, and it will see, okay, the content length is 2, but here in the body section we only have 1 byte of data, so it will try to wait to read other part of the data, but it will not get it, and we will see the request timeout. So if I send it again, you will see the same result. Okay, so error, read timeout again. Now what we need to do here is, if we just put here, let's say space between the content length and the colon, okay, and we send the request again, you will see there is a difference in the response. Okay, now this time you can see communication timeout, server error, communication timeout. So why that happened? What is the meaning of this space here? Why it is important? So the front end server forward just the header to the request to the backend server, and the backend server read content length, and the content length is 2. So there is only 1 byte of data, so it will wait for other bytes or the rest of the data. So this is a typical scenario of 0 CL, where the front-end server always see content length or assume content length as 0, and the backend server will interpret the content length. Okay, fine. So from here, we will basically move to a static resource of this application, because the static resource cause the backend to respond immediately or quickly. So we will not have to suffer from the different responses. Accessing the static resource will give you the immediate response, and you can get the fruitful results from that. So static resource, what I can use it from here, like SVG files like this one, and we can use CSS files, we can use JS files like this. So these are the static resources. Fine. So first of all, I'm just going to take this static resource, which is a SVG file. I'm just gonna copy it and paste it here. Fine, and send the request. So as expected, this is very normal. Okay, and we get the content of the SVG file. Now what we are going to do here, we are going to create a nested request. One more request with the get. So I'm just going to say a header, which is Z, and this header value is going to be our another request, that is going to be a get request slash here I'm going to use another static resource like JS file, like this one. Okay, so I'm gonna take this, copy it back to the repeater, and just paste that here. Fine. And I want this request to be the get request, because it will not see any data in the body section. I'm gonna convert it to the get, and the content length is going to be up to here. Okay, after the space or where your second request started. Okay, so from the very first get request to the point where your second request started. And if you see this one, you will find here there are 53 bytes of data, and I'm gonna put it here in the content length section, send the request. So what basically you see, this give you the content of the SVG file, because the first request is going to that static resource, that is a SVG file. But what if I try to get put another nested request to another resource? So if I send it multiple times, and if I get the data or the content of I forgot to put here http/1.1. okay, now that's completed. Okay, now you see we get the content of the JavaScript file before we get the content of the SVG file. Fine. So when we send this request again and again, and we get the different response, like the first response we get the content of the SVG file, and in the next response we get the content of the JavaScript file. So this is because the backend server basically interpret the content length, and the front-end server say, okay, the content length is 0, it will not see because of this space, and it will send only the headers to the backend server. So once it will send the header to the backend server, which is this, where the content length is 53, so it will say, okay, this is the first request and this is the second request. Okay, fine. So now we need to exploit this, but we need to chain the overall process, because it is going to be a difficult part if you try to chain these vulnerabilities and also the nested loop here. You need to send the request into the loop. There are two ways you can create the actual exploit, and you can put here a lot of tabs with the smuggled request and the in the flow of the exploit, and then you can create create those as a group, tab group, and then you can send those requests into the sequence. Okay, and the second, which is easy and that makes your life a bit easier, is the turbo intruder. So what I'm going to do here is just send any request that contains the host header to the intruder. So I'm gonna take the web root request and send it to the turbo intruder. Okay, and in the turbo intruder I have to basically create the flow of the exploit. Okay, so what would be the stage 1, what would be the smuggled request, what would be the stage 2, and reveal and victim, and then we will run our loop. So basically this is the skeleton. Okay, because I already chose it before, so it just gave me the particular exploit Python script which I need to execute. But if it is your first time, you see here it's saying last code use. So if you just drop down it, you will find here example /0cl exploit. So we need to choose this exploit. Okay, and you see this is the exploit we will use, and this is the skeleton code. We can change it into as we need. Fine. So while loop, this is going to be the same because this script basically proof of concept. So rest of the things are same. We need to just make little modifications here. Okay, so the first part here in the stage 1, what I'm gonna do, I'm gonna write it and come back, and then I will explain once we get succeeded into the successful exploit of this vulnerability. So I'm just gonna manipulate it or change it as we needed, and we'll come back. Okay. Okay, so I put the things into the sequence here, and let's just first of all unleash the attack, and we see whether we get success or not. Okay. Four oh four 302. Okay, things are going well. We should anytime get here. Okay, and you can see the alert is popped up. That means maybe it captures our request. But we are waiting for the Carlos to access the application while the exploit is going on. Okay, I'm gonna halt it so that we can see maybe there is something wrong in our turbo intruder script, and we will confirm everything is fine. We see where we made a mistake, and then we will come back, okay, to the exploit. So because it should not take that much time, I need to check out the script. So back here, halt. Okay, and then we will go to the configure and we will check what we did wrong here. Okay, so the first one is gonna be the post request with a resource that does not exist or anything. We have host header. Okay, so basically this will take the host value from this header, Okay, it's totally fine. Content length it will take automatically. Get request seems perfectly fine because we have that get request with post ID 8. Okay. And we took the same payload. Okay, here we put some data. Okay, and in the last I say, okay, once the lab is solved, it will say congratulations, you solved the lab. So if it sees congratulations, it will cancel the engine to process. Actually, instead of that, because of the hexadecimal thing, I'm just gonna put here something which is not in the hexadecimal. So let's say m is equal to 1, and here I'm gonna say m n. This could be the reason, maybe. Okay, so everything seems perfect. I just changed few parameters here, like this data what I put here and the header into m and n. And although this does not affect according to me, but let's see. So I'm just going to attack again. It started. Actually, the lab got expired. I don't know why. So I make it refresh again, get another lab, and then I'm doing the same thing with the same payload. Because you can see here the host header, the host value gets changed. So before we had host value like 0ADE008. Now we have 0A8, something like this. So make sure before you initiate the attack, just refresh one time your application to check it whether it's still alive or not. And once you send the attack, or once you initiate the attack, just click on some random request. You should see here 200 OK, 302 OK, 404. But if you see forbidden 403 or other response status code or other response headers by saying something else like 500 403, so that means you are not on the right way. Okay, here you can see congratulations, your lab is solved, and you can see the attack is being stopped here. Now I'm going halt it and configure, and here I'm going to just explain what basically I did. So what we did here in the parts in the segments, we try to initiate that automatically by the turbo intruder with a sequence so that the attack will be performed on the application. Okay, so back here there is a method named as queueRequest, where you can see there is a target and word list. 2 arguments are here. The most important part here is initiating the engine of the burp. Okay, and it's saying we need 10 concurrent connections, and one connection per request. We need one connection, and initiating the burp engine, maximum retries per request we don't need it, and the timeouts we need 15. So this is the very first thing to initiate a method, because we see here def, that means this is a method, this is the name of the method, and it needs 2 arguments. So what basically we are doing in these stages, stage 1, stage 2, smuggled and victim. So first I'm just going to describe about the stage 1. So the goal of the stage 1 is to make the front end and back end server keep disagreeing on where the request end. This is the most important part. Now how it is done, because it uses the content length that will be replaced by the length of the stage 2 chopped. Okay, that is replaced by the length of the stage 2 chopped, because this is the 0.cl attack. The front end might think the body is 0 byte, because front end will always see the content length as 0, so it will not consider any body. It will not consider any bytes in the body or any data in the body, and sending the headers to the backend server while the backend waits for the missing bytes. So this is what we are trying to achieve in stage 1. Now if you just go to the while loop, because we are initiating this, we keep initiating or keep working on these attacks with the while loop. Okay, so if you see the second line of the while loop, where we basically add these 3 stages: stage 2 chopped, stage 2 revealed, and the smuggled. So what we are doing in the stage 2 chopped, so this basically provide the missing bytes to the backend server, which is waiting from the stage 1. And then we have stage 2 revealed. So what this stage 2 revealed will do, this is a valid looking header that completes the previous broken connection. Okay, now you can choose anything here instead of 404, anything that does not exist, fine. And then we go to the smuggled, because here we add these 3 stages: stage 2 chopped, stage 2 revealed, and smuggled. So smuggled is where basically actual thing happens, or we need to execute the XSS payload. So here we are doing that. So first of all, this is the actual exploit. The first thing, it targets the post request with the post ID is equal to 8. Okay, and it contains the XSS payload into the user agent, which we saw before. And crucially, it ends with a short content length of 5. Okay, so the content length is 5, although here we have only 3 bytes of data. Now what victim this one is using, this is the last piece here in the while loop. You can see the third thing, we are going to the victim. So this is for the Carlos user or any other victim who is going to access it. So this basically simulates the request Carlos or the victim makes. Because of the desync in stage 2, the backend server will prepend your smuggled request to the front end of the Carlos real request. Fine. So this is the thing what we try to achieve. So this is another method, handle the response, how we are going to handle it. So it has 2 arguments, request and interesting. So here we are just defining some condition. If you have the victim and you see congratulations in the response, then just request the engine to cancel further request. Fine. So this is the thing. It's a little bit tricky to understand, but it's not impossible. Fine. It's a little bit tricky because of the way you need to exploit it. Okay, so that is the thing. And that's why if you I would attack again. I know the lab is expired, but still I want some data to go so that I can, okay, this is what I need. So here you can see, okay, here you can see these are the requests. So this is what, from this request, basically you will understand what we are trying to do. So you saw that in the while loop, we attached stage 2 chopped, stage 2 revealed, and the smuggled one. Okay, so this is the stage 2 chopped up to here, where we put the header. This is the last line of the stage 2 chopped. M is the header and its value is n. Then the second request, which is stage 2 revealed, that request starts from here, and this is what we did here before in the request. This is exactly what we did, right? This is what we did. So we do the same thing here. And the third thing, we put the smuggled. Okay, the smuggled request, where we have the user agent and its value is a payload for the XSS. Fine. So just check that out. I hope you understand it. I hope you enjoy the lab. I'm gonna see you in the next video. Bye.